Hi everybody, today we're going to be doing some AP chemistry. We're going to be balancing and stoiching equations. This is probably one of the most important yet some of the easiest things you're going to have to do in this class. So let's go ahead and get started. It just takes some practice and that's what you're going to be getting today. So let's start off with the parts of an equation. So in the equation above, we have CH4 plus O2 and that gets transferred into CO2 plus H2O. So the first part of this equation shown before the arrow, so all of this right here, okay, all of that right here is called a reactant. So those are the chemicals that are actually reacting. And then the second part of the equation, which is right here, after the arrow, is called the product. It is what is being formed from the reactants. So let's talk about states of matter. So we have ZnS plus HCl AQ plus Cl2 AQ plus H2G. So the S, as we can see in the first part of this, is is a solid. So this is telling us that Zn, whatever that might be, is a solid. We don't have an example of a liquid here, but if it were an L, that would tell us that whatever the thing in front of it is a liquid. So for example, if we had H2O, we would have an L next to it because H2O is a liquid. So gas would be right here. As we can see, this tells us that hydrogen is a gas. And then the second one here is AQ, which is aqueous, and this just tells us that whatever our substance is, it is dissolved in water. Okay, so let's talk about the law of conservation of mass. So this tells us that the amount in must equal the amount out. In other words, the reactant must equal the product if we want to get more scientific. And so this is why we must balance our equations before we start stoiching. So balancing our equations is our first thing, and then we use that to stoich our equations. So let's go ahead and look at this equation. C, carbon plus H2O, is equal to CO plus H2. So on the left side of the equation, remember we're comparing from left side of the arrow to the right side of the arrow. So on the left side of the arrow, we have one carbon, and that's the only carbon we have. So we have one carbon. Now if we look on the other side of the equation, we also only have one carbon. Now let's look at our hydrogens. So here we have two hydrogens, and here we have two hydrogens. So our hydrogens are equal. And here we have one oxygen, and here we have one oxygen. So our oxygens are also equal. If they are not equal, we must equal them out, which we will do a little bit later. But so basically, in order to stoich them, our in must equal our out, which is the law of conservation of mass. So that's what comes into play here. Okay, so let's look at example 1. We have a little bit of Sb plus some amount of oxygen, which gets us 4 Sb and 6 oxygen. So this equation is really easy because it's even numbers, so we don't have much like hard work. So let's see. We have 2 oxygens here, but we have 6 oxygens here. So 6 divided by 2 equals 3. So that means we have 3 right here. And Sb we have 4 of. And since we have nothing here, it just tells us that there is a 1 here. So divided by 1, and that gets you 4. So we have 4 of this. So now if we check our work, on the left side of the equation, we have 4 Sb. And on the right side of the equation, we also have 4 Sb. Back to the left side, we have 6 oxygens. And on the right side, we also have 6 oxygen, which tells us we balance this equation right. Let's look at it as a different example. So this one, we have some amount of Ca plus some amount of Al plus Cl3, which becomes some amount of CaCl2 plus some amount of Al. So let's see, how are we going to go ahead and approach this problem? When we are given big values like this, one of the most important things to do is look at your big values. And so our big values are going to be right here and right here. So one side of our equation has 3 of chlorine, and our other side of the equation has 2 of chlorine, which means that 6 is our factor that both of them can get into. So that means we must have 2 of this and 3 of this. So our chlorines are matched. So now on the left side, we have 2 aluminums, which tells us on the right side we must have 2 aluminums. So let's go ahead and put 2 aluminums. And on this side, we have 3Ca. This side right here, we have 3Ca. So on this side, we must have 3Ca. Everything has to be equal. Okay, so next we are going to stoich an equation. There is nothing, no words that are going to be able to help you do this except for practice. And the only way you're going to get practice is by looking at an example and then doing some examples. So I'm going to be showing you 2 examples, and then I have an example for you to do. Then we'll go over it together. Let's start with example 1. Okay, so this first example is an easy example because the equation is already balanced. But let me read the question first. How many moles of CO2 are created when 1.43 moles of octane C8H18 are burned in excess oxygen? Um, you can just ignore excess oxygen. You can ignore this whole part. When something tells you it is burned in excess oxygen, excess anything, ignore it. It's just telling you that to just confuse you. You don't need it for now. So ignore it, which I have done here. So now we're gonna go ahead and stoich it. Like I said before, this equation is already balanced, which makes this so much easier. But yeah, let's go ahead and stoich it. So we are given 1.43 moles. Sorry, my mouse is making sounds because my stencil broke yesterday. So please don't mind that. Moles. And now we are going to multiply that. So this is going to be over 1. And we're going to multiply that by the moles of CO2. CO2 is right here. We have 16 moles of it. So we're going to have 16 moles of CO2. And understand, bear my handwriting. I'm so sorry. And underneath that, we are going to have 2 moles of C8H18. I'm going to go ahead and explain this once I write everything out. And I'm just going to write OC for octane because there's no way I'm going to be able to write that without not being able to read it. And that's it. So why did I put that there? That's all you need to do. So let me show you what I did, why I did it, how I did it. So we took our number of moles of octane, 1.43 moles, and we just put a 1 over it. You're going to do that to start every problem. Then we are going to multiply that. Remember, we're going to cross multiply. So our moles of octane are going to go on the bottom. So we have 2 moles of octane. I don't know why it's not written here, but we have 2 moles of octane. I think I messed up. We have 2 moles of octane. Otherwise, this equation wouldn't be balanced. And then we have 16 moles of CO2. And we do that because we're looking for our CO2. And when we go ahead and do 1.43 times 16 divided by 2, you can get around 11.4 moles of CO2. Okay, let's move on. So question number 2, it asks us how many grams of nitrogen N2 are needed to react with 50 grams of hydrogen H2. So this question's a little funky, and here's why. Right here, it tells us we have the moles, so we can automatically convert. But here it tells us we have grams. So this is going to add an extra step into our equation. But first, we actually have to balance our equation. Nothing here has a value, and they all need a value. So we're balancing. We have 3H, means this has to become 3, this has to become 2. Since those are balanced, we have 2 nitrogens, we have 1 of that. Great, equation's balanced. That says how quick it needs to be because that's the easy part of solving this. Soon we're going to start theoretical yields and stuff, which is not going to be covered in this video, but the next we're going to be able to need to do this quick because it is time consuming. So let's start solving this. We're going to be given, I'm not going to label this because my handwriting sucks, but I highly recommend you do because you're going to lose track of everything if you don't. So we're going to have 50 grams times, you're going to have your 1 mole of H2. Oops, hold on, sorry. What did I do? Okay, sorry, you have 132. Let's restart this. I'm so sorry. So we'd have 50, then you would have 1 mole of H2, and you had 2.06. So let me explain where this came from. The molar mass of hydrogen on the periodic table is 1.008. However, this tells us we have 2 of that. So we have to multiply that by 2 when we get 2.016. So because we're given in grams, we had to do that step. Last question we were given in moles, so we didn't have to do this step. This converts the 50 grams to moles. And now we are going to take our 1 mole of N2 and put that over our 3 moles of H2. We can ignore NH3 because the question doesn't ask us anything about NH3. And then we multiply all of this by 1 mole of NH2 and then the molar mass of NH2. So the molar mass of nitrogen, N, is 14.01, but like the hydrogen, we have 2 of it. So it's going to be 28.02. Okay, and then we have to multiply. So we're going to multiply 50 times 28.02, then divide by 2.016, divide by 3. And when you do that, you'll get about 232 grams of N2. Okay, I really hope that makes sense. If it doesn't, just go ahead, rewatch this part, and I will go explain more on the next slide about the next question. Okay. So question example 3. Calculate the grams of hydrogen required to produce 82 grams of ammonia NH3 from N2H2. All right, I'm going to let you guys go ahead, solve this on your own, and then we'll go over it together. So take as long as you need, pause me, go ahead and answer this question, and then we'll go over it together. Okay, so I hope you got an answer. I hope you got the right answer. Now we're going to go in and do this together. So first things, we're not given an equation. The first thing we were given a completely balanced equation. The second example, we were told to balance the equation. Now we have to make and balance the equation. So we are going to be given some amount of N2 plus some amount of H2, and that is going to react to form our product, some amount of NH3. So we have three hydrogens, but we have two hydrogens here. You already know what that tells us. We've done this quite a bit. We have two hydrogens, so that's just one hydrogen. I'm sorry, nitrogen. Does that make sense? That equation is now nicely balanced for us. So now let's go ahead and answer this. Okay, so this just kind of gives us the equation now. Now we actually start stoiching it. So we are going to take our um, 82 grams of ammonia. Okay, let's start. So we're going to take our 82 grams of ammonia and we're going to multiply that by the molar, we're going to divide that by the molar mass of ammonia, which is 17.034. And if you're wondering how I got that, I took 1 mole of nitrogen, 14.01, plus 3 moles of hydrogen, 1.008 times 3. And when you add that together, you're going to get 17.034 over 1 mole of um, ammonia, sorry. Then we're going to take our molar mass. So we have 2 moles of ammonia, and we're looking to find hydrogen. We have 3 moles of hydrogen. Now we're trying to find it for 1 mole of hydrogen, so we're going to have 1 mole of hydrogen. And our hydrogen's molar mass is 1.008, but we have 2. So that's going to be 2.016. So when we multiply 82 times 3 times 2.016 divided by 17.034 divided by 2, you are going to get about 14.56 grams of H2. Now this number might vary because of how you rounded your numbers. Different periodic tables give you slightly different molar masses. So instead of saying, for example, for oxygen, instead of saying 15.99999, they just say 16. And so that would leave your answer off by a little bit. But if it's written response, your teacher will count it. And if it's not written response, just round, right? If you get 14.57, but the answer is 14.56, you know you did that right. Your rounding was just a little bit off. So that's how you do this type of question. I hope this helps. This was part of it. In the next video, we're going to talk about theoretical yield, percent yield, limiting reactant, access reactant, all of that stuff. So stay tuned. Thank you guys so much. Hope this helped.